Thank you very much. There's somebody that I would like you to meet. His name is Mika. And I think you'd agree, Mika is pretty cute. Now, I'm biased because Mika is my soft-coated Wheaten Terrier puppy. As I speak to you today, Mika is about 18 months old. But 4 days after this picture was taken, on July the 11th at 1:35, my wife sent me a text message that said that Mika had suddenly become very unwell indeed. I took Mika to the vets at 4 p.m, and they said, your dog is sick, we need to keep him in, we're going to figure out what happens over the weekend. By Sunday afternoon, the vet called me to say Mika needs an emergency operation to stabilize him. We want to get him well enough that Monday morning, if he survives the night, you need to take him to a specialist vet. Now, I need to reassure you of a couple of things. Mika is fine. 1 week later, thanks to that specialist vet, Mika was restored to normal. He was also restored to normal thanks to £10,000 and the unique way that my wife buys the most expensive version of everything she can find. Normally, if I'm honest, I find this slightly annoying, but I'm thankful because only because of this is my dog alive today, and only because of this do I have the perfect visual aid to explain everything which is wrong about the way that we engineer radio. My dog has a street value of around £1,500. He has an intrinsic value of absolutely nothing. And yet the insurance company was willing to fix him for £10,000. And this is what is wrong with radio. In IT, we call this the cats versus pets problem. Pets have a name, pets have a personality. We love pets and we will fix them for £10,000 when they go wrong. If you have cattle, if you farm as a herd and not consider the individual, if it costs £1 more to fix the cow than the cow is worth, then the cow is a burger that same afternoon. That's how you think of it, as a herd, not as an individual item. You see, in our old world, in the worlds of pets, everything was hand-tuned, it was customized, it was a specific piece of hardware. But as we move to this standardized, industrialized, generic world, then we need to think of software-defined, not just software. You see, the software is what we see on top. That's the user experience, that's the workflow. We've made that workflow change. But when we move to software-defined, we're saying the actual hardware is entirely generic. So instead of having individual machines with individual names, you have a server 1, server 2, through server 673. If server 178 dies, you don't even know. No one comes rushing with a spanner. They come along, they toss it in the garbage the next day because the workload is already running on generic and identical server 637. This is how hyperscale compute works. This is how Amazon can do what they do, how OpenAI can do what they do, and we can learn from this same methodology and technology. I have 2 dogs, you'll see the second one later. I have one more pet. This is my laptop. My laptop is absolutely a pet, and my laptop did actually die earlier this year. The SSD failed, and it was fine because the data was backed up. But that's not fine, because 9 months later, my new laptop is still shit, because it doesn't have all the little bits of config, all the little tools, all the utilities. I'm still going places and finding things that my new laptop does not do. Because I had backed up the data, but I hadn't backed up the personality, the functionality. My laptop wasn't generic. It carried all that config on it. That means it's a pet and not cattle. And here's the dirty truth. We build petting zoos, not data centers. Occasionally people tell me that the cloud is just somebody else's computer. No, it isn't. It's a completely different way of orchestrating computers. It really is. And some people say, well, a rack room is just our data center. Honestly, no, it isn't. It's a beautiful thing, it's very well engineered, it's very resilient, but it's a petting zoo, it's not a data center. It's full of individual pieces of equipment with their own personality and their own uses, and when something goes bang, somebody comes running and they tap it with a spanner. We need to learn from the philosophy and psychology of how computers are orchestrated at scale. Not because we are the same scale as Amazon, but what we can do is leverage the same tools and the same technologies and the same techniques that allow this to happen. Instead of all those completely customized boxes instead of all those pets, then we need to move to something where we can use standard compute. Why? Because we think that we've moved into the world of IT because around about 23 years ago, we put our audio on the network and then we started applauding ourselves and think, that's it, we're now in the IT world. Well, friends, in the last 20 years, a lot has happened in the world of generic compute and IT, which we haven't necessarily embraced. 20 years ago, a good friend of mine, Steve Church, looked at a network switch and thought, this is doing pretty much exactly what a custom audio router is doing. We can use that generic technology to replace something which costs an absolute fortune. If Steve was alive today, he would be doing a talk about RoCE. This is how you move data at scale now in data centers. Directly copying, RDMA just means remote direct memory access, copying the memory on one computer to the memory on another computer without touching the operating system, without touching the kernel, pretty much without touching a driver. And if you think about the way that we orchestrate stuff in virtualized clusters today, well, you might as well move audio memory to memory in the same server because they're running virtualized in the same machine. We can now copy it from server to server using generic technology which is available today. What does that mean? Instead of moving audio in milliseconds, we can move audio in microseconds. Instead of using only 50 to 60% of our network bandwidth, you can use 95 to very, very close to 100% of the network bandwidth with absolutely deterministic performance because we're not just leaving a little bit extra in case we need it later on. We're not just relying on over-specifying our network to try to hope that the audio and the video arrives. There is technology now which was designed in data centers for moving memory in real time between graphics cards, between high-performance compute, high-frequency algo, my old world before I retired from prostitution. In that world, every microsecond costs you millions and millions of dollars. This stuff works, and it works at scale. So this is a crowd which is used to change, and we embrace change and technology. We don't fear change, but we do fear networks. And everything I'm talking about sounds like magic. It sounds like I'm saying you can simply instantly and silently move stuff at scale. And yes, you can when you start to try to treat your network as a fabric instead of a series of individual switches. If you focus on what you want, not how and why that thing is going to happen. You see, one switch is an opportunity, two switches is a problem, 5 switches is a disaster, 200 switches or 1,000 switches in a data center is a completely different animal. But it's also a solved problem. So we're trying to encourage people to think about software-defined broadcasting, which doesn't mean what we did 30 years ago when we digitized analog stuff, or what we did maybe 15 years ago when we took that digitized stuff and we put it on a computer, or even what we've done in the last couple of years where we run that on generic compute. That's about the software. I'm talking about the way that we define the entire architecture and the entire principles upon which we're building our facilities. Because when the software has the configuration on it and that's living on that device, you can spin up your laptop on a completely new laptop because everything is carried. No pets, everything is cattle. Unfortunately, we've just heard a lot about the EBU. They, along with all of these other fabulous broadcast partners, are doing great work at building a reference architecture called the Dynamic Media Facility, which demonstrates all of this. The bottom 3 layers are that generic compute. That's the stuff that we borrow from the world of hyperscale. The 2 gold boxes you see on top, that's the stuff that you see on top, the application. That's the stuff that suppliers like us do, the media functions underneath. The magic and the bit that the EBU are accelerating so we can merge those 2 worlds of the things you touch with the things that are now available is that media exchange layer. That's allowing everybody's memory to interoperate and transfer media at scale in an open source way between different vendors. And so if you are a fan of a QR code there, you can get to the EBU page on that MXL, on that media exchange layer. And this is absolutely free for anybody or any vendor to implement. And it means we can now begin to move media at scale using open source protocols built on top of the way that we would now build hyperscale compute and that we would want to architect things. Of course, there is one difference. We live in a media world. So while this world tells us where everything is and how to get it, there is one more dimension. We live in the 4th dimension of time, And the BBC have done some great work along with Amazon and others on what they call the time addressable media store, giving a fourth dimension to this hyperscale compute world, which allows us to see where everything is, what everything is, and most importantly, when everything was. So you can request audio in a way which is fully described, fully retained, and you're able to reconstruct stuff from the bottom back upwards. So, I sort of implied earlier on that we need to be less Mika. But fortunately, because I love Mika very much, and I forgot to say this when I was speaking earlier in the year somewhere else, and at IBC, people just kept coming up to me and saying, is Mika okay? Is Mika okay? Yes, Mika is absolutely okay. That's Mika on the left. That's his older but smaller brother, Ozzy, on the right-hand side. And I don't want you to think ever that I would say you need to be less Mika. I think we all need to be more Mika. Number one, we need to be soft. Mika is a soft-coated Wheaten Terrier. That means he's soft on the outside. I want us to be soft all the way through to the core, to be defined by software, not just soft on the outside. Second of all, I want us to be dynamic. We're really good at building rigid, resilient things with a single purpose that they're very robust at doing. The future belongs not just to hyperscale, but to the dynamic ability to build stuff which has agility and which is able to change very rapidly. So we need to be soft, we need to be dynamic, and yes, Mika is hyper. I got another text from my wife just a week ago in which, fortunately this time it was sort of better news. The text just said this: your dog has been kicked out of daycare. Yes, Mika, the dog that was nearly dead just a few months ago, was kicked out for being hyperactive. They couldn't calm him down. Mika is hyperactive, he's dynamic, and he's soft. And so should we be. Thank you.